Hi everyone and welcome back again. So last video I'll talk about AND gate. So today I'll talk about OR gate. So before I move to the OR gate functionality, I need to mention you again that OR gate is working for Boolean or operation like the plus sign or binary addition sign for binary addition operation. Okay, and then another thing in binary system we have two number or two digit is 1 and 0. So 1 means the in electric circuit lamp will be 1. We will just consider imagine it. We'll just think in our mind, and switch on will be also binary 1, and lamp off will be binary 0, and also switch off will be also binary 0. So now if I want to move here or gate, as I told previously in during AND gate time, how many cases we can have? We will have just for 2 input here means 2 to the power n means 2 to the power 4 will be 2 to the power 2 will be 4. That means equal to the power 2. Input is 2. So it will be 4 case again. Okay. So these two input switch A, switch B, and output will be the lamp. Just one thing first about lamp, and then A plus B. Right? A plus B. So now at first this is battery. So in battery, this is the plus side, and this is the minus side. So electron will always try to move plus to minus sign, and electricity will move the NT of electricity will move the minus to plus sign. This is in electric circuit is a system for transport of electricity. But now here, the precondition to move electricity, of course, we must need to move electron. So for example, at first, electron is moving from here. So the switch 1 is still turn off and switch 2 also turn off. So this is the in first case, whenever both switches turn off. Turn off means it's 0. And switch 2 also turn off, it means 0. So what will happen? There will be no electron here in this point, because electron will divide this two part. First part switch 1 and or second part switch 2. But there is no part who can that can move forward, so that we can see the light will be turned on. But this time both switches turn off, so electron cannot move, and there will be no electricity here, so that the lamp will be turned off. Now in second case, if I turn on switch 1, just turn on switch 1, but switch 2 is still turned off, so electron will come here and electron will divide in two parts. At first electron will try to go to switch 1 and choose this part. So whenever electron will see the switch 1 is turned on, so electron can move in this way and come here, and electron can move finally until light, and that's enough. So that this time whenever electron see, electron cannot move here, so all electron will move in this by switch 1, and then they come here, and there will be electricity whenever electron can come here, and light will be turned off. Light will be turned on. So this time switch 1 is 1, but switch 2 turn off. So what the final result? Light will be turned on. Now in third case, and during third case, this time I will turn off switch 1, but I'll turn on switch 1. Just switch 1 is turn off, the same, but switch 2 is turn on. This means like electron will come until this point, then it will divide into part. Some part 1 will be there and part 2 will be here. But part 1 cannot move here, but part 2 can move by switch 1. Whenever say this there have only one way, then part 1 also come here and it will move, and that's enough. Whenever it's come here electron, then electricity also can move. in this way, so that whenever electricity can move, this time the lamp will be turn on. Lamp will be turn on. Now, at the last case, if I turn on both switches, what will happen? If I turn on both switches, electron move in this positive to the side, one part here and another part here. So electron this time part 1 can move in this way, part 2 can move in this way, but in this point it will be again one part, and that can move until the light. So that, and this time electricity also can move in this way, so light will be turned on. That means whenever switch 1 is 1, switch 2 also 1, but this time light will be also turned on. So in this case, we can see whenever minimum just at least only one switch is 1, or at least one is true, this input, if I am talking about in logical thinking, like true and false, if only one true, both will be if only one true minimum, the output will be true, or if only one output will be 1. Just one switch 1 minimum, this means light will be 1. What was during the AND gate? That time it was whenever both switches will be turned on, that time only will be true. Same like in logical operator, same like in logic, both when in AND gate, in AND operation, whenever both will be true, that time both or all will be true, that time only output will be true. So that's all until now about OR gate. Next video I will try to talk about NOT gate. Thank you.